Okay, hello everyone. It is 5:43 p.m. Saturday, June 21st, and I'm gonna have to make this video a little quick because I gotta leave at 7 o'clock to go get some dinner with my girlfriend and some friends. So I think I'm gonna do some backtracking today. I'm honestly at like a fork mode right now where I don't like any of these, which is fine, you know. That's why we're doing these. We're not doing these because I can magically do them. We're doing them because I need to learn them. Oops, hit some glass. Okay. So given an integer nums of unique elements, return all possible subsets. Power set. Oh, here you go. It's power set. The solution set must not contain a duplicate set results. This includes backtracking. I've done like backtracking in a minute. So my first thought would be, I go and I have I'm not gonna lie, like I have an idea of how to solve this, but I don't think it's the right way. I think I'm not. I never actually truly learned like the true way of doing backtracking. I just kind of started doing my way. So like I kind of want to be careful to not, because you could do this kind of like incorrect. Huh?
O of n times 2 to the n squared time? Dude, that's so slow. What the hell?
Is that actually the time? I mean, I guess that's the power set. Jesus. It is straightforward. This is like the baby steps to learning DP, including not including. I'm not gonna actually look at the code. I'm just see backtracking, bit manipulation, no DP, bit manipulation. So okay, sorry, it's cheating a little bit there. I didn't see any of the code though. I don't think I truly understand like how. so hit this one. We do include and exclude. Did we hit this too? We do include and exclude on both of them. And we hit this through, do include and exclude on them. Oops. Okay, let's see it. So we have empty. We have empty. I'm gonna just write it out. We have 1, 2, we have 3, we have 1, 1, 2, we have 1, 3, we have 2, 3, and we have 1, 2, 3. That's backtracking? Is that really backtracking? I feel like I'm not truly understanding, like, if I'm doing this right. I never like learned the actual like truth of backtracking. It's just something like that I was doing, like, yeah, that's backtracking. It's like, okay, I guess so. So like I feel like I don't know the descriptive, like what's counts and what doesn't count, like where the border is on like what is right, what is wrong. What's up, big guy? What? What? Oh my days, Max. You're gonna be fine. What do you mean, none type? Right. How's that a none type? I'm declaring it right here. Huh? Dude, what? Oh man, I hate coding. It's a love-hate relationship. Like, well, what exactly is a null here? Dude. How? How is this a null? What are we talking about, man? Huh? Oh, wait, no, it's not. Okay, wait, hold on. Sorry. Oh, I'm so confused. Then what is the problem? Okay. Wait, what? How to add to an array in Python. Dude, I'm so done with this rinky-dinky ass bullshit. I think I understand. New array. I'm gonna say old array equals array, and then array dot append. You know what? No. I'm so tired of this. I'm so tired of this. Why? It's like. Why is the empty array being qualified as null? Yeah, I don't know, man. Yeah, I have no idea. I don't know how to do this. I'm gonna have to watch the video.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem subsets. So we are given an integer array num. So what is a subset? Well, let's say we have 1, 2, 3 as our input. One subset, of course, would be 1 right by itself. Another subset would be 2 by itself. We could do 1, 2 together. Now, what happens if we do
I did
2,
this in my
1, right?
algorithms
We just swap
class.
the order. Does that count as a different subset, or is that the same as this subset? Well, they're the exact same. We don't care about the order. This is not a permutation. This is a subset. So it's not a permutation. It's a subset. So we do not want to include duplicates, and this counts as a duplicate. We're not going to include it. And 3 is another subset. 1, 3, 2, 3, 1, 2, 3. The original input is technically also a subset. And we also don't want to forget the empty subset. So no matter what we're given, an empty subset is technically a subset of this as well. So if we want to create all the subsets from this input, we have a choice for every single element. So for this 1, we have a choice of include the 1 in our subset or not include the 1, so we get an empty subset, right? So we have that choice, and we have that choice for every single input element. So in total, we have 2 choices here, 2 choices here, and 2 choices here. So this is going to be 8, or in other words, 2 to the power of n, where n is the size of our input, right? So this is the number of subsets, and we don't want the number of subsets. We actually want the subsets themselves. So how long could a subset be, right? Well, we could have a subset 1, 2, 3, right? The size of our input. Should we make it? Because given the constraints of this problem, we don't want the number of subsets. We want the subsets themselves. We have to make it inefficient. So with this in mind, we can just jump straight into backtracking, which is the brute force way of solving this problem, but it's also pretty much the most efficient way. So like I said, for each of these elements, we have a choice. So I'm going to draw the decision tree. So first, we can choose to add one or not add one, and that will give us 2 subsets, one subset with just 1 and 1 empty subset. So along this path, we can decide now, do we want to add 2 or not add 2? So with one decision, we will add 2, and the other decision, we won't add 2. So we'll get 1, 2 as one subset, and the other subset will just be 1 by itself. And we can actually repeat that on the right subtree for 2. So we can decide to add 2 to this empty subset, or we can decide to not add 2 to the empty subset, in which case we'll get a subset with 2 by itself, or we'll get the empty subset again, right? This is where we're just not adding anything. And lastly, we can decide whether we want to add this 3 or not. So if we add the 3 to this subset, we'll get 1, 2, 3. If we don't add the 3, then we will remain as 1, 2. And we can repeat that decision over here, and that's basically what I'm going to do now, right? Repeat that decision for every single one of our, like, you can call them nodes or you can call them leaf nodes. That's just what we're doing. So if I add the 3 here, we'll have a 1, 3. If I do not add the 3 here, we'll have the 1 by itself. So you can kind of see these are 4 unique subsets, right? Now let's build the rest of the 4 from over here. So I have the choice, do I add 3 or do I not add 3 to this subset? If I do, I will get 2, 3. If I don't, I will have 2 by itself. And you can see these 2 subsets are different from the subsets over here. These are still unique. And lastly, we can choose to add 3 to the empty subset, or we can choose not to add 3 to the empty subset, in which case we'll get a single empty subset. Now you can see we keep multiplying by 2, right? So here we had 1, we multiply by 2, now we have 2 subsets over here, right? We go down again, we multiply by 2, now we have 4 subsets over here, right? Then we go down one more time, multiply by 2, we have 8 subsets, and they're all unique. This is our result. This is what we're building with this problem. This is backtracking. Now if you want to know how to do this backtracking solution in code, let me show you right now. So let's do this with backtracking. So we're going to have a result list, which we're going to add these subsets to, and I'm going to do this with backtracking depth first search, and I'm going to write this function inside of this function so that we don't have to pass in this variable or this variable.
What? I hate this solution. Okay. So this is everything. It's just the problem is... Honestly, we're gonna do this. Okay. I like the solution more. I think this just messes... This works better for the way my brain operates. So is backtracking literally just like branching off? Can't be right. Okay. No, we're not talking about frequency. No. Wow. God damn it.
What?
I feel like I'm reading this like 100,000 times before I can understand it. Ooh, wait, this is actually kind of tricky. What's up? What's good? Oh, I gotta draw this out actually. My first thought is basically take each number and then throw it in. So 2, and then I say, hey, can I do? Then I branch off. I go. Oh, I have 0. Okay, so here's how I'm thinking. We have this empty set, which is 0, and then thinking we go. Two and nothing. And from here I can go maybe not. Is it always sorted? Then we go back one. We can't add 3. We can't add 5. So closes that off. Then we go back one. We can add 3. And that's it. It closes off. Can't do anything else with that. Then go back when we go. And then we can't add 5. Wait. Okay, we should probably should make it where we don't go back. Like this, yeah. Probably should just like only go forward. That could avoid duplicates. So then you can keep a tracker. So here, like to keep a tracker, I would say like I'm at index 0. Okay, now I'm at index like 1. No, sorry, I'm still at index 0. So okay, so you could check from where you're at. This one I try to do 1, it doesn't really work out. Index 0, index 0. Now I'm at index 1. So I can't go backwards, so this will never exist. I can stay at index 1. I think that's what we'll do. Take an index, we'll take in a value. I think that's how we'll do it. I'm basically going to say Yeah, it seems pretty out there, I'm not gonna lie. Oh, infinite loop. I had a feeling I was gonna get infinite loop. Oh no, my Wi-Fi turned off. Why is my dude? Ah! Why does my Wi-Fi keep going out? Holy crap! Hey, that worked. Hey, that worked. I feel like that's like a slow approach, though. No. Wait, what? What is the second? Huh? Oh, current to pop. Okay, I see. His way of doing it's interesting. I understand it. I don't agree with it. I think I prefer my way more, which honestly, he got to Google, so realistically speaking, who am I to say anything? His way is probably the more efficient and probably the more readable way to the average viewer. Given a collection of candidate numbers, okay, so let's just go do this again. What's the difference? Oh, each number will only be used once. What's up, bro? What's up, bro? Whee! I'm gonna be lazy. Well, no. I don't know if that's right. Ooh, infinite array? Oh, or infinite running? That's not good. Runtime was 0 milliseconds? What was the slowdown? What? One, two, five. What does that have to be like sorted or something? 116. 26. 125. What? It's gotta be sorted. It's gonna slow stuff down. Ah. Why? Oh, you know what? That's so valid. Just sort it first. Oops. Still getting duplicates. How do I get rid of the duplicate problem?
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve a problem. We had the input and we were able to solve it very simply with recursion. For a given element, either you include it or you skip it. So we would have had 10 or we would have skipped 10, and then from here we would have chosen from the next element we can either include 1 or we can skip 1. From this side though, we're not quite at 1 yet. We can actually choose to continue including 10. We can have multiple occurrences of 10, or we could have skipped it, and in that case from here we would have started choosing from 1. So here we could have chosen 1, or we could have skipped 1. And so that was a very simple 2-branch recursion. But we can't apply the same here. And the reason for that is, at some point with this example, we might include 1, and then eventually we might get to 7, and then we might include 7 as well. If we were to have skipped this one, we could have gone down this path, we could have included the 7, and then we could have included the 1 that came after it, and we would have ended up with duplicate combinations. So we want to avoid this case, and we can, believe it or not, still do so with 2-branch recursion. It's going to be similar to how we eliminate duplicates in threesome. So this is the trick behind eliminating duplicates. The issue here is that when we choose to include 1 or choose to skip 1, we don't want to end up with another 1 on the same path where we decided to skip 1. So how can we make it so that we never see another 1 again if we decided to skip it? Well, this is the trick. First, you take the input array and you sort it. So I'm going to redraw this in sorted order. Now it's sorted. Why did I put it in sorted order? Because I want all duplicate elements to...
So if I skip, then I have to skip to the next thing.
be adjacent. It's not necessarily important that we go through the elements in sorted order.
So oh. Hey, very good. Nice. All right, that was pretty quick and easy. We kind of used our hands to get through that one. I'm hungry right now, but yeah, thank you for watching. Let's see, I think. What are we on? Look at all this coding jargon. We're on day 27, and we have completed 62. Yeah, I feel like we're a little behind, but that's okay. I got a comment on one of these. Okay. Yeah. Maybe not as much as I wanted to get done. But that's okay. I need a... Crap, I have like no days left until July. I gotta start ironing out my resume like stat. Get that done. Because July's around the corner and you know what time it is. It's time to start applying for jobs. Ugh. The full-time market is scary. But, you know, we do what we gotta do. Alright, thank you for watching, everyone. And I will see you tomorrow.